Our world is built on concrete. It's the foundation of our modern world. Skyscrapers, bridges, roads and dams all rely on it. Concrete is the second most used substance on Earth, after water. It has enabled incredible progress, supporting economies globally. But this progress comes at a price. The problem is not concrete itself, but how we make it. Traditional concrete production is very polluting. It carries a significant environmental burden, affecting our climate and ecosystems. We must acknowledge this hidden cost, and we must find better ways forward. The biggest problem is carbon dioxide, or CO2, making traditional concrete releases huge amounts. Cement, the key ingredient, is the main source of these emissions. About 8% of global CO2 emissions come from cement production. This comes from the chemical process called calcination. Limestone is heated, releasing CO2 directly into the air. For every ton of cement made, roughly a ton of CO2 is produced. Concrete also needs a lot of sand and gravel, leading to unsustainable mining. This extraction causes significant ecological damage. The current way of making concrete is not sustainable. The climate impact is too severe. The good news is that solutions are emerging. Innovation can help us solve this dilemma. The world needs a new kind of concrete, one that is strong and durable, but also kind to our planet. Researchers at Northwestern University have developed a groundbreaking material. This new concrete is actually carbon negative. This means making it remove CO2 from the atmosphere. Imagine buildings that fight climate change. Imagine roads that clean the air. This is the promise of carbon negative concrete. It offers a pathway to sustainable construction, and this innovation could transform the building industry. It gives us a powerful new tool to build a better future. With smart thinking and dedicated research, we can decarbonize tough sectors like cement and concrete production. The Northwestern material is a prime example. It inspires us to aim higher. How does this new concrete work its magic? The team at Northwestern uses an electro-geochemical process. It uses electricity to drive chemical reactions, forming cement-like materials. These reactions use CO2 as an ingredient, not as an unwanted byproduct. Instead of heating limestone, this process can use various calcium sources, even industrial waste products. The system uses electricity, ideally from renewable sources. This electricity helps convert dissolved CO2 or CO2 captured from industrial flues. It locks this CO2 into solid carbonate minerals, which act as the binder in concrete. This means the concrete itself stores carbon. The CO2 is sequestered safely within the material. This is how it becomes carbon negative. The more of this concrete we make and use, the more CO2 we can potentially remove. It is a form of carbon capture and utilization. This scientific breakthrough is truly inspiring. It paves the way for greener building materials. The benefits of this new concrete go further. It is not just about capturing CO2, it also addresses the sand mining problem. The process can be adapted to use different aggregates, including recycled materials or waste products. This reduces the need for virgin sand and lessens the pressure on our rivers and coasts. This innovation promotes a circular economy. It can use waste streams from other industries, like steel slag or mining tailings. These might otherwise end up in landfills. Instead, they become useful building materials. This reduces waste and conserves resources. The material itself is designed to be strong, meeting or exceeding current standards. Builders and engineers need reliable materials. The goal is a concrete that is better for the planet and great for building. This all adds up to a powerful solution for sustainable construction. What does this mean for our future? The potential is immense. Imagine cities built with carbon-negative concrete. Every new building, every new road could actively help heal our planet. Instead of contributing to climate change, our built environment could become a carbon sink. The applications are as broad as concrete itself, from foundations for homes and offices to large infrastructure projects like bridges, and even for smaller items like paving stones. Anywhere traditional concrete is used today, this new material could potentially take its place. The scale of impact could be enormous, transforming one of the world's largest industries. Of course, there are challenges ahead. Scaling up production and ensuring cost effectiveness are big ones, but these are solvable challenges. With continued investment and commitment, we can bring this technology to market. Let us build that future, one green block at a time.